If a normal person could take one simple and relatively effective step today to greatly increase their chance of living past 100 or 90, what would it be and why?
Yeah, people never like the answers I have to this question. Unfortunately, the fundamental, most effective thing that most people can do is to get involved one way or another in the longevity movement. In other words, to contribute to the effort to hasten the development of treatments that don't currently exist. Because ultimately, everything we've got today, even though it's terribly well-meaning, and it does, in some cases, do a little bit of good, it only does a little bit of good. You might get an extra year or two if you're very lucky. And I really mean very lucky as well, because the fact is, different things are beneficial to different people, and you only find that out by trying. So essentially, the only general advice is to listen to your body. But as I said, it's not going to give you very much anyway. Whereas every little step that we take as a group to bring forward the defeat of aging is going to be a very different matter indeed.
And how can people get involved in the longevity movement?
Right. Of course, different people have different skill sets and different circumstances and so on. That defines the answer to that question. The good news is that there are no number of ways to find out how to do that. In other words, basically, if you're keen to get involved and you don't know how, all that what you used to be able to do was look me up and write to me and ask me, and I would do my best to answer such questions and to help people get involved in a productive and impactful manner. But of course, it's only little me; it doesn't really scale. So now there are one or two other ways to go about this. There's a wonderful organization that I seed funded a few years ago. It's called the Longevity Biotech Fellowship, and they run retreat a few times a year around the world where maybe 50 or so people of this kind, newcomers to the field, with a variety of different backgrounds, will get together and they will learn some actual information from mentors, people like me who've been around a long time. But the most important thing is they will meet each other and form collaborations and so on. So this is an extremely effective way to go about it. And there are various fora you can ask about things like this. So yeah, there are reasonably good ways to identify ways to get involved.
Yeah. And how did you first come to believe that aging is a problem we can actually solve rather than an inevitable part of life?
So for me, it's the other way around. What I came to believe rather late in life, around the age of 28 or so, was that other people don't think that. To me, it's completely incon- inexplicable that the general view of aging is that it's somehow woven into the fabric of the universe and, that it's inherently immutable. Because it's completely obvious that the body is a physical thing. It's like a machine, right? And as such, it inflicts damage upon itself in the course of its normal operation, same as any simple machine like a car. And preventative maintenance is a well proven way to transcend the warranty period of simple man made machines. So it's completely obvious that it should also work with sufficiently sophisticated maintenance on a really complicated machine like the human body. And until I met and married a biologist when I was 26, 27, I had never, it was so inconceivable to me that anyone could possibly not think this, that I'd never done the experiment of actually discussing it with anybody. My first wife was a biologist and actually a lot older than me. She was already a senior professor. And it just gradually dawned on me that we were never talking about aging. So I started raising the topic, and that was when this terrible revelation happened. And eventually, after a couple of years of coming to terms with it, I decided I had to switch fields. I was doing quite well in my previous field, which was artificial intelligence research. But I was only doing that because I felt that it's a shame that we have to spend so much of our time doing stuff that we would not do unless we were being paid for it. The problem of work is an actual problem. But the problem with aging is quite clearly a very much more serious problem that causes much more suffering and death and so on. So that's why I switched.
And speaking of AI, do you think how are them these two different fields potentially combining together in a positive way? Do you think how do you think AI will improve our chances of anti-aging and longevity?
Yeah, AI research and AI now is a completely different beast than what it was back when I was working on in the 1980s. And now, of course, it actually works. You can do a lot with AI that you certainly, it was a big shock that works as well as it does. Yes, so AI is very much already integrated into biomedical research in general, not just in aging. We've got probably still the most conspicuous example is this thing called AlphaFold, which determines the three-dimensional shape of a protein from its amino acid sequence. That was an absolutely massive breakthrough that enormously speeds up all manner of biomedical research. So that was huge. There are lots and lots of things, ways to use AI to discover drugs, to build new molecules, even to change the amino acid sequence of a protein dramatically so that it does its job better than it previously does. This is something that made great progress in the past several months, actually. Yeah, huge applications.
And what about nanotech? How's that potentially going to benefit the longevity movement?
The word nanotechnology has gone through a whole bunch of different definitions. I don't really think about nanotech as a thing. The original definition of it revolved around what was called atomically precise molecular manufacturing. And it's definitely an exciting field of research, but it's still very much at square one. There's a huge amount of fundamental advances that has to be made before it gets on anyone's radar in terms of application. Then at the other end of the spectrum, people have started using the word nanotechnology to be synonymous with nanomaterials, which basically just means small particles. There's plenty of that going on. So, for example, there's a company that I'm quite close to named Nanotics, which manufactures particles that go into the circulation and that bind to stuff in the circulation that we'd like to get rid of. And they're very cleverly designed in terms of their actual structure, so they don't have side effects that would happen with simpler molecules. This is something that I guess you could call nanotechnology.
Yeah. And is for increasing our longevity and anti-aging, is it likely going to be a drug? What kind of technology do you think it's going to be? Like
Yeah.
mechanism or something like that?
So my answer to that actually pretty much explains the emphasis that I'm taking at LEV Foundation in terms of what studies we're doing. Aging is a really complicated thing. It consists of a whole bunch of ways in which the body damages itself in the course of its normal operation. And then, of course, the types of damage that it does to itself are different, which means that the methods that we have to develop to eliminate that damage are also different. So adding all that up, basically what it means is that the way we're really going to bring aging under proper medical control is by a divide and conquer approach, by doing a lot of different things to the same people at the same time. And then we have to ask, what are those things? Some of them will be straightforward drugs, but many of them will not. Many of them will be gene therapies, cell therapies, immune therapies, a more complicated thing. Now, that's not to say that it'll really look different from the point of view of the recipient, the patient, because basically nearly everything that we're talking about will be injectable. In other words, in the same way that the MMR vaccine, people think of it as just a vaccine. It's actually 3 vaccines for different things, just that we administer them all at the same time. I wouldn't be at all surprised if we end up with single injections being given to people that have 300 things in them. But that's the direction we're going. But the main thing is that it's not just going to be things that you can take as pills. Not because pills, by definition, they go through the stomach, and a lot of things get broken down there, and you don't have limited what's called bioavailability in terms of what gets into the actual circulation. And I'm very sure that the things we need to do will include things that cannot be administered that way, have to be injected, which, as I said, pretty much defines why I do what I do at LEV Foundation. There are a number of other groups doing studies on mice that are in other ways quite similar to what we're doing, but they're only working on things that can be supplied in the mouse's food or water.
And speaking of kind of research and stuff that you're doing, what are some of the biggest advancements and breakthroughs, or like soon to be advancements and breakthroughs that are currently happening right now in longevity?
Of course, you never know what's going to happen. If we knew what we were doing, it wouldn't be called research. That's one of my favorite answers. But in terms of breakthroughs that have happened recently, yeah, it's very exciting. As I say, I focus on mice, not just because mice are mammals and people relate to them more than they relate to flies, for example, but also because they live relatively short lives, 2.5 years or so, and therefore we have the ability to actually determine whether they live reasonably quickly, whether something makes them live longer. this is something that I feel is very important in longevity research. A lot of my colleagues try to get away from it. They try to say, oh, let's measure health span. Let's not worry about life. And that's all very well, except that when the wider world looks at what you've done, you've measured that in some way or other, your mice or your dogs or whatever are healthier at a given chronological age than they otherwise would have been. People will say, yeah, that's all very well, but you haven't fixed aging, have you? And they'll say, what do you mean? And they'll say, you haven't made them live longer. And you say, I might have done. And they say, yeah, you might not have done. And I'm going to believe that you didn't. So you've got to measure lifespan. And so that's why we work with mice. So what are the advantages? The extraordinary thing is that even though we always have to keep in mind what I said earlier, that it's a divide and conquer problem, and you've got to do a lot of things at the same time to the same animal, nevertheless, there are a number of things, an accelerating number of things, that you can do just one thing, just individually to mice, and they'll make them live a bit longer, which is completely extraordinary, really. It means that if you like, the knock-on effects of fixing one thing spread out and permeate the entire metabolism of the animal. That's why I was able, 3 years ago or so, to design an experiment putting 4 things together, all in the same mice at the same time, with the goal to see whether we could get additivity, getting more life extension when we put them together than what we did if we did any one of them individually. And it worked pretty well. We definitely got additivity. We didn't get the magnitude of the effect that we were hoping to get, and I believe that's fundamentally because we only used 4 interventions. So the next experiment I want to do will involve 8. And but the point is, I couldn't have done an 8 intervention experiment 3 years ago because there just were not that many things that had already been shown to extend lifespan, especially if you start late in life. This is a critical thing. We start our experiments when the mice are already in middle age. And I feel if you don't do that, then again, people don't really relate to what you're doing. They think, oh, I've missed the boat. So yes, middle age. And now, in the past couple of years, while our first experiment was ongoing, paper after paper had come out showing this or that new thing works. So now we're spot for choice. I could do 2 different 8 intervention experiments in parallel starting today if I had the money, which I don't. They cost about $6 million each, these experiments. The first one, because it was only half the size, cost $3.5 million. We've identified a few cost savings, so we're cutting it down a bit, but it's still, a lot of money. But then again, when I say it's a lot of money, think about it. It's a lot of money by the standards of typical mouse experiments, but it's a really insignificant amount of money compared to clinical trials.
And what are some of these interventions that you're doing, and how do they work in extending the lifespan of these organisms?
So I can't really answer the second question very well. And the reason I can't is precisely because of this knock-on effect thing. Honestly, this is a big surprise. This started, there were hints of it maybe 15 years ago when people first started implementing some of the more aggressive damage repair approaches in mice. Now, back then, the experiments that were done were very artificial. One had to create clever genetic models in order to do the experiment. But it became clear that one particular type of damage repair, the removal of senescent cells, had far bigger knock-on effects than anyone would have guessed. And the story has continued, as I say. But what I can certainly do, of course, is tell you what the interventions are. So in our first experiment, I said we did 4, we really only did 3, because the 4th one that we put in was not a damage repair approach. It was a drug called rapamycin, which is known to be what's called a calorie restriction mimetic. In other words, it essentially tricks the mice into thinking they're not getting enough food, even though they actually are. And the reason that's beneficial is for the same reason that it's beneficial if you actually genuinely give the mice less food than they would like. Nature has evolved a response to that, because of course it happens in nature. Famines happen, right? And it turns out that it's better for the organism, better for evolution, if you have a response, if you basically readjust your metabolic priorities in favor of hunkering down, so to speak, and surviving the famine, rather than throwing your resources into growth and reproduction. The reason that makes sense, of course, is that if you have offspring during a famine, the offspring die of starvation before they can have their own offspring, so you've wasted your energy from an evolutionary point of view. All right, rapamycin does it quite well, definitely reproducibly extends life. So we did this as a kind of positive control. But then in addition, we had these 3 other interventions which were very much damage repair. So one of them was what's called heterochronic bone marrow transplant. So we killed a lot of young mice and scraped up their bone marrow and purified out the stem cells from it, and then injected those stem cells into old mice in a manner that allowed some of those stem cells to survive long term. And it was beneficial. Then another thing we did was telomerase gene therapy. So we gave a viral vector that had been engineered to express this enzyme telomerase. But again, it's been found to extend life in other people's hands, a couple of studies. So that's good. And then the third one was a senolytic, something that gets rid of senescent cells that I mentioned a moment ago.
It's incredible that you're already seeing progress and signs that it is extending the life. You mentioned senescent cells. Are these kind of the same as them, like zombie cells?
Yeah.
Could you explain what they are?
Yeah, zombie cells, that's a kind of colloquial term, but it means the same thing. Yeah, so basically what happens in the body is that occasionally cells get into a kind of altered state, a kind of aberrant state, where they are doing different things from what they were built to do. Maybe they're also doing the original things, but they are, in particular, they are not dividing, but they are secreting certain substances. Now, it's believed that this response evolved for a few reasons. It seems to be beneficial in wound healing. But the thing is that, of course, wound healing doesn't take very long. So the idea is senescent cells, when they arise, they ought to go away again after. Sometimes senescent cells can arise when a cell detects that it has suffered DNA damage. And in that case, it responds by going into this frozen state where it is unable to divide. And that is believed to be a defense against becoming a cancer cell. But because of this secretion thing I mentioned, there are reasons why senescent cells are bad. So we have mechanisms in the body, in fact, especially around the immune system, to get rid of these cells. But those systems don't work 100%. So some senescent cells survive long term, and the overall load of senescent cells in the body gradually rises over time. And yeah, this is generally believed to be rather bad for you because of the stuff that is secreted. In fact, there's all manner of ways in which it's been shown to be bad for you. Basically, if you can get rid of these cells, if you can augment the machinery that the body already has for getting rid of them, then that's going to be beneficial.
And what happens to the body when these things are excreted from the senescent cells? How does it damage the body or affect the body? What can it cause?
So there's a bunch of different mechanisms. And in fact, this is still a...
Hey guys, first of all, I want to say thank you. There's one person who's been sharing the podcast more than anybody else, and that is you. The only reason why this podcast continues to grow is because you are sharing it. And my only ask is, if this podcast has provided value to you, or you think it'll provide value to somebody else, then if you could send them a DM of the link or a screenshot to the show, that would genuinely make my day. And it's the only way the podcast will continue to grow. That's my only ask of you. Thank you very much.
Research area, so we probably don't know all the answers to that question. Way back when the whole idea came along, initially senescent cells had been identified and people thought they were harmless. People thought they had become essentially useless, but they weren't doing any active harm. And then a brilliant, absolute titan of the field named Judy Campisi back in the mid-90s came up with the idea that maybe they were actively bad for you because she figured out that they were probably secreting nasty things. And back then, I remember chatting with her back then in the late 90s about this. Her view was that there was only really one mechanism of damage, namely that even though these cells were sometimes getting into that state as a way to avoid becoming cancerous, nevertheless, the things they were secreting might actually increase the chances that cells nearby would become cancerous. And that's probably true. But now we know that these secreted molecules get into the circulation, they go everywhere, and they may have effects that go way beyond promoting cancer. We simply don't know all the possibilities.
And speaking of cancer, how does longevity kind of research and anti-aging medicine and stuff, how does that relate to cancer prevention research? Because what would be the point of living to 100 or having stuff that can make you live that long when you can still get stuff like cancer? Is this all intertwined?
It's all intertwined, absolutely. The terminology here is a little bit confusing. Some people don't really include cancer as part of aging. I think that's dumb. I think that it's perfectly clear that nearly all cancers happen predominantly to older people. So obviously it's part of aging. The reason why there's this kind of spectrum of opinion with regard to terminology there is because cancer is a very different type of aging than more or less anything else. In fact, you can really think of aging as a kind of trade-off between cancer and degeneration. We essentially progressively shut down our regenerative capacity, our ability to rebuild cells and so on, in favor of stasis, and we do this precisely as a kind of macro version of what I just said about zombie cells, in order to limit the ability of cancer to kill us too soon. But that doesn't make it not part of aging, not at all. So absolutely, we work very much on all of this, including cancer. And there's been huge progress in cancer as well. One difficulty that cancer research and cancer therapies have always had is that every cancer is different. Not only that you have different types of cancer in different tissues, but also that cancer arises through genetic mutations. And therefore, of course, it's different. Even two cancers in the same person would be different. People have gravitated in general to treating cancer as not a disease, but as a collection of diseases and going after each one individually. However, the problem is that cancers are really ingenious. Because they're genetically unstable, they figure out ways to evade what we do. We've got a lot better at stopping that from happening. In particular, we're getting better with the immune system. There are a couple of breakthroughs that were made 10 or 15 years ago now that have really invigorated the field of cancer immunotherapy. And that's going great. There's still a lot of progress to be made, but it's going okay. Personally, the thing that excites me the most about this area is a technology that targets cells that are maintaining their telomeres. So telomeres have a somewhat unfortunate reputation within the wider world, where people think that the shortening of telomeres is a bad thing. And it can be a bad thing. It happens when a cell divides. But of course, it's a good thing if you don't want the cell to divide. And that's the case if you're talking about cancer. So it turns out 90% of human cancers turn on high levels of this enzyme telomerase that stops telomeres from shortening when cells divide. And so there's a new approach, a new drug that kills cells that have done that. And it's taken a bit of a while to move through the system, same as drugs tend to do. But it's now in phase 2 clinical trials in Australia, overseen by a company named Maya Biotechnology, MAIA, for anyone who wants to look it up. And I am really excited by it.
And when do you think that drug and also other like senolytic drugs, and when do you think they'll soon be available to everyone? And
yeah, of course, the clinical trial process is glacially slow. And the reason it's glacially slow is basically because of the bloody public opinion is, just indescribably, horribly risk averse. When one person died in a clinical trial, all hell breaks loose and things are shut down for years. Whereas when millions of people die because it takes 5 years longer to get something on the market than it ought to have done, it doesn't make headlines. It's outrageous. But that's the public for you. They're not very good at reasoning with uncertainty. Yeah, phase 2 clinical trials is better than phase 1. It's better than just working in mice, but it still could be a little while. And this is partly why I am also a big advocate of ways to essentially sidestep the standard regulatory process. There are various places around the world, most notably a special economic zone in an island belonging to Honduras in the Caribbean, that are making their own rules and are essentially working to become global hubs of medical tourism. And that is a good start. It's not very good, though, because, of course, you have to have a bit of money to be able to do that, and you want to do it better. There's another initiative that happened in the US not long ago, where in specifically one state, Montana, they passed legislation that basically said that if you can get a doctor to prescribe you something that has not been approved, just so long as it's gone through phase 1 of clinical trials, which means there's a huge number of drugs that have got that far but no further, then you can have it. But again, there's a financial issue because in the US, healthcare is paid by insurance, not by the government, to speak of. And as such, you have to pay for it yourself because this is not covered by insurance. So there's still a long way to go in terms of improving and modernizing regulatory things. The FDA, the organization that oversees regulatory approval of drugs in the US, they get all the crap. They get all the blame. But they shouldn't really, because they're just implementing the law. And the law is what it is because of the bloody public.
But do you think it's more the media telling the public rather than the public?
No, no, absolutely not. The media doesn't help. Certainly the media, they are in business to sell papers or whatever, right? And therefore they pander to the pre-existing prejudices of the public. And therefore they do somewhat entrench them, as you say. In fact, of course, it's not just the news media, it's also the entertainment industry. One of the things that one of the biggest problems I have in my outreach work is the fact that there's a steady stream of blockbuster movies about a post-aging world, and they're all dystopic in one way or another, because they all start from completely idiotic assumptions about how a post-aging world would be terrible. And they, as I say, entrench what I've called the pro-aging trance. Same deal. The media will perhaps entrench and pander to pre-existing risk aversion, excessive risk aversion, but I don't think they're really responsible for creating it.
Yes. And how do you see the post-aging world? What does that look like for you in an optimistic way?
Oh, I don't really even think about it. I think about it a bit. Of course, there's a whole bunch of things we don't know about the distant future. I never think about the distant future because 30 years ago we didn't have the internet. It's just impossible to imagine. There's far too many unknown unknowns. But of course, the near future is a different matter. I think that we are, with 50% probability, only about 12 to 15 years away from bringing aging under comprehensive medical control. And that's pretty close. But what's even closer is the point where the world begins to appreciate that we are quite close to bringing aging under comprehensive medical control. And that, I believe, could happen in as little as 3 or 4 years from now. When that does happen, all hell will break loose, because an enormous amount of how the world goes round, the global economy, is based on industries that revolve around how long people think they're going to live. At the moment, very nearly everybody in the world believes that they're going to live only a few years longer than their parents did. And literally in a period of a week, that is going to transition into a world in which most people think that they've got a good chance of living essentially indefinitely, and certainly a very great deal longer. And you know what? People who have made that change in expectation are going to want different life insurance policies and health insurance and inheritance arrangements and pensions and God only knows what. These are the big ticket items determine that drive the global economy, and nobody's ready for it. It's absolutely terrifying. So that's the kind of thing that I think about the near term.
Yeah, and surely in the long term, though, there might be some, again, speculative, but other industries that thrive because people stay alive
Oh, of
longer.
course, every industry will thrive because of that. Because essentially, at the moment, we spend the most insane amount of money keeping sick people alive, right? I mean, literally, probably 80% or more of the Western world's medical budget goes on that. And we won't have to do that anymore. Now, of course, we will have to spend some money to administer these preventative medicines that stop people from getting sick in the first place. But that even at the beginning, when those medicines are fairly expensive to develop and administer, it'll be a tiny fraction of what we're currently spending, which means these medicines will pay for themselves many times over really fast. That's the answer to another question that comes up all the time, which is essentially, won't this only be for the rich? Fact is, once it's seen to work, complete game over. Any government, even if they're not interested, even if they're not thinking about the humanitarian imperative, even if they're not thinking about the electoral imperative, which most governments actually do think about, then just the sheer straight up mercenary economic imperative is quite enough to mandate that governments will find ways to, through taxes or subsidies or whatever, to ensure that these medicines are available free, irrespective of ability to pay, to absolutely everybody who is old enough to need them. It'll just be, the return on investment will be massive and rapid.
Yeah. And will basically everyone be fit to work almost forever or for their entire lives?
Well, that's right, yes. Basically, there will be lots of chronologically old people, but almost no biologically old people. However, of course, to slightly put a swerve on your question, we have to also always remember, and people often don't do this, that the post-aging world will be different in a lot of other ways as well because of other technologies that are also coming along. Of course, we talked earlier about artificial intelligence. Fact is, even rather conservative organizations like the United Nations predict already that most of the jobs that exist today will simply not exist in 2050. So we shouldn't really think of work in the way that we think of it now. The idea of work being something that you're looking forward to retiring from, we're working on that. Retiring will be a matter of you retire when we don't need you anymore because we have enough machines doing all the work. And of course, there has still to be a way to distribute wealth equitably, but there will be more wealth to distribute because machines are cheaper than people. And so, of course, there are already ideas out there for how to do this, something called universal basic income, which I think is going to take a whole bunch of refinement. At the moment, it's a decidedly blunt instrument, but still, that's the general concept. And there are a whole bunch of other things like self-esteem. Many people derive their self-worth from their job. And if they're not getting a paycheck anymore because they're not actually doing things they need to do in order to get that paycheck, then there's a case for trying to replace that and give them other ways. But we're definitely not going to be in a world of essentially full employment anymore. In the Industrial Revolution, when we eliminated enormous numbers of jobs in manufacturing and agriculture, they were all replaced by this new thing called the service industry. And that worked fine. But it's not going to be that way this time. How many people do you need in the entertainment industry?
And does that mean what happens then? Once that happens, what do people do with their time? Do they just pursue their hobbies and creative things and just live off that basic income?
I think so, yes. Basically, what do people get their self-esteem from, really? Each other, really. It's community. It's interacting with other people. And at the moment, when people have to spend so much of their time doing stuff that they would not do unless they were being paid for it, that of course takes away from the time that's available for social interaction.
And what do you think you would do once that happened? What would you do with your time?
Oh, I'd probably just spend most of it staring at the sky from my hot tub and doing math.
Sounds great. We mentioned how you don't do too much to try and increase your longevity day to day, right? Is that correct?
That is correct, yes, but that doesn't mean that it's a recommendation. The reason I don't do much is simply because I'm doing very well for my age already. I'm one of those repulsively lucky people. I can eat and drink exactly what I like and nothing happens. I don't even need to do any exercise. And I'm also lucky in the sense that because I'm a high-profile figure, I end up getting very discounted or free tests, very high-end tests of things that might be going wrong with me. It's very reassuring to be told authoritatively that I really am as healthy as I feel I am. And of course, things can change. So right now, for example, I do take one supplement. Historically, I didn't, but now it has been determined that I have a genetic variant in a gene called MTHFR that predisposes me to a certain metabolic instabilities, in particular high circulating levels of something called homocysteine. There's a particular variant of vitamin B12 that fixes that. So I take that now. I'm totally open to doing things that it seems I do actually need. But at the end of the day, again, it's a personalization thing. You need to pay attention to your own body and decide what you need. And most people need to do things that I don't need to do at my age.
Yeah. And how did you find out about that specific
Oh, it was
deficiency?
one of those things I just mentioned. Some high-end company decided it would be good advertising to sequence my genome or whatever.
And what does that process look like? How do they
Oh,
do
yeah,
it?
it doesn't look like anything. They just take a small blood sample and stick it in a machine.
Oh, okay. Do you think that's going to become widespread in the near future? Will
Well,
the cost of that?
it already is fairly widespread. It only costs $1,000 to sequence a human genome now. It used to cost $100 million or something.
Yeah. And yeah, like you said, you've only just started taking supplements. And why did you advocate maybe not to take supplements before? Why didn't you take supplements before?
So again, I didn't advocate because it's just because I personally have not had any metabolic deficiencies that indicated that any supplements would be valuable. There's one thing that I did know about, namely high homocysteine, but it didn't seem to have any knock-on effect, and so I didn't do anything about it. Now, however, since it's been determined why I have high homocysteine, I might as well fix it.
And so, for the average person that hasn't got their genome sequenced and stuff, would you just say to have kind of like a balanced diet and no extra vitamins if they don't feel anything's deficient?
For sure, the value of a balanced diet is unarguable. The vitamins are an approximation. Because there's all manner of things in a diet that we haven't even identified yet. But yeah, as I say, some people need supplementary stuff, even if they are taking a balanced diet.
Yeah. And do you have any kind of foods that you would recommend people to avoid if they
No,
weren't really?
no, it's quite important to understand that what a balanced diet means, it revolves 90% around what you have. A bad diet, the thing that's bad about it is not what's in it, but what's not in it. If you only eat fast food, processed food, it, that is deficient in valuable stuff, micronutrients. So there's nothing wrong with going to McDonald's once a week. It's just if you end up spending your entire time there, then that would be a problem.
Yeah, yeah, yeah. And why is public awareness and support critical for advancing anti-aging science, and how can listeners get involved? You mentioned at the start, but why? Could you elaborate more on the public awareness and support
Sure,
part?
yeah. Ultimately, it's all about money. Research costs money. And money is only forthcoming if people who are in a position to write checks decide they'd like to. So then who's going to do that? The people who've got the most money are governments because they've got taxpayers' money. But unfortunately, they want to remain in government, and therefore they won't do things unless they feel there are votes in it. So just getting vocal and making sure that one advocates for it is very important. And of course, there are different ways to advocate. You're doing one of them right now because you're doing a podcast. That's really important. I do a huge number of interviews, and that's why, to raise awareness, raise quality of understanding of this issue. That's huge. Of course, if anyone's listening who is in a position to write a check, even a small check, then please do. We have a donate page. I'm sure you'll put it in the show notes. But yeah, so I spend a lot of my time speaking to wealthy people who can write big checks, and also, as I say, doing interviews, trying to reach out to the larger number of people who can write small checks. And that's how the world goes around. That's how I get stuff done.
Yeah. And do you see more companies coming into this field in the future? How many companies are there now, and how many do you think will arrive?
So this is the biggest thing that's happened in the past decade, really. That 10 years ago, there was no private sector in this field to speak of. There was an anti-aging industry, but that consisted entirely of snake oil, basically, of things that had to be as charitable as possible, had not been proven to have any benefit. Now we have an absolute proliferation of small companies, and indeed some of them are no longer small, that are very much working in this area. It's enormous, and it made all the difference. It's got a huge. This is why my timeframes are as optimistic as they are now. 20 years ago, I said it would be about 25 years before we got aging under comprehensive control. 10 years ago, I was still saying 20 to 25 years. In other words, my timeframes have been slipping and slipping, basically because there was no money. Now I'm saying 12 to 15 years. So it's hardly slipped at all in the past 10 years. And that's basically why. I will emphasize, however, that this infusion of private sector money is very unevenly distributed. Everybody who wants to make money, basically, they want to make it tomorrow. And that means that there is a huge bias towards short-termism, towards the low-hanging fruit. It just happens that within this divide and conquer ecosystem of therapies that we have to develop, some of them are harder to develop than others. And if you're focused on making money tomorrow, then you're going to avoid those things. So those things are still criminally underfunded. And indeed, they're not really in the private sector by and large. They're mostly still being pursued philanthropically. What we do at LEV Foundation has an even more deep-seated version of that problem, because what we're doing is we're combining things that other people have developed. So even if there is IP, intellectual property around that, it's owned by other people, and it's tricky and complicated cross-licensing stuff. But worse than that, a lot of the things that we're developing are not even patentable or not even protected. Yeah, so essentially we are irretrievably non-profit. And as such, what I do is I appeal to people who trust me enough that they're willing to write me a check even though they're not going to get any of it back.
Yeah. And speaking about, you saying how it's going to be injections and stuff like that, is it going to be like a daily injection? Is it going to be one injection, do you think? Or is it going to be like a yearly injection?
So these are things that we really can't be sure of yet. But my guess is that it's going to be more like yearly, if that, maybe even less often than that. And that's because this is damage repair. The thing you inject doesn't just stabilize things, it actually rejuvenates you in one way or another. So that means that you're going back many years in your biological age in one or another respect, or maybe in a range of respects. And as such, there's no real need to do it again until your body has damaged itself again to an extent that nullifies what you removed.
Yeah. And would it be like going to the dentist then, like a yearly dental checkup? Oh, I'm just going to have my yearly
Yeah,
injections.
I expect so.
Wow. That's fascinating. And you're saying could it be 12 to 15 years? Is that your prediction
I
from
think
now?
I think there's a 50-50 chance that we'll get there that soon.
Wow. And do you think if we reached artificial superintelligence, that would dramatically increase that prediction?
You mean reduce it, I assume?
Oh, reduce it. Yeah, yeah, sorry, yeah.
Not dramatically. There is a tendency to believe that unless AI just kills us all, that it will just fix everything overnight on its own. But the thing about AI is you have to remember that it doesn't create data out of thin air. It creates insights out of data. So it has to be given the data. Now, one can think in terms of the AI can tell us what experiments to do, and then it can use the results of those experiments to tell us what experiments to do next, and so on. But that cycle is slow. And therefore, however super the artificial intelligence is, there's a limit to how fast it can go. So that is why it is absolutely imperative that we do our very best to generate such data, relevant data of all types, right now, before we have this super intelligence that may or may not occur in the next few years in the first place, right? We can't be sure it will. So that is what's not happening at the moment to a sufficient extent. Too many people, too many billionaires, even billionaires who have decided that aging is a very bad thing and they'd like to fix it, are putting their heads in the sand with regard to the impact that AI can plausibly have in the near future.
Yeah. And what will be the physical effects of these drugs? Will it be like, will you end up looking different, or will it be all internal in terms of will you lose a lot of weight? Will your skin become clearer? Will you get less wrinkles, or will it all be these kind of internal things?
Yeah, all of the above. The outside of the body is the easy part. If the inside of the body, the reason cosmetics don't really work is because they do. The reason they work a bit, but only a bit, is because the outside of the body is pretty easy to fix. But if it's being increasingly poisoned by the inside of the body, which is aging, then the effects diminish. Similarly, putting that the other way around, if the inside of the body is basically youthful, then the outside of the body can almost look after itself. But yeah, you'll definitely not just feel and function like a young adult, you will look like a young adult as well.
Wow, that's incredible. Just a few last questions. If you could give your 20-year-old self one piece of advice, what would it be?
Yeah, there's all manner of platitudinous things I could say. Honestly, if I look back, I didn't make all that many mistakes, which is good news. But yeah, of course, I chose a rather distinctive path in life from an early age. I always knew that what I wanted to do was make a difference to the world. And by definition, in order to make a difference to the world, you have to do things that not many other people are doing. So I decided very early on that I didn't want to have kids because having kids is an extremely time consuming thing that stops you doing other stuff. And it's something that a lot of other people are perfectly good at. That seemed like an extraordinarily bad way to spend one's time if one wants to make a difference to the world. And so I've made those kinds of decisions. I wouldn't change all that much.
And how do you said you've avoided quite a lot of bad things and stuff. Like, what could be what's your mindset behind avoiding certain things, and how can people avoid making too many mistakes that could set them back in life?
Of course, the mistakes that matter the most are the ones that have a big impact in the near term that can't be rectified. Don't die of stupid things. Wear a seatbelt, even in the back seat. People ask me what I do differently now I got into this field, and I say I don't accept seminar invitations to dangerous countries.
It's good. Good idea. And what book, or even like a single line from a book, has had a profound impact on your life and you recommend people reading?
For me, there isn't any answer to that question. I get asked that quite a lot, and I've tried to think of actually a good answer, but there really isn't a single thing. There are a few people that I look up to, role models, but for me, I think the main thing is not so much to be inspired by a single sentence or whatever, or even a single book. It's really to aim high, to not be ground down by failure.
And how do you have the confidence to aim high for those people that maybe aren't confident?
So a critical thing about making a difference to the world is that you don't have to know that you're going to succeed. Science is all about being part of the community that's trying to make a difference. For example, there's a small minority of scientists who go through their lives with a goal in life to win a Nobel Prize. And the rest of us, the majority of scientists, really aggressively look down on that ambition because Nobel Prizes are awarded after the fact for having had an achievement. And every scientist knows that there is a huge, vast, indescribable amount of luck involved in being the person who happened to make this or that breakthrough. You've just got to put yourself in a position where you might be able to contribute. And if you don't contribute, that means you didn't contribute, because all of the time that you were not succeeding in winning a Nobel Prize, you were communicating and conversing and giving and inspiring and giving ideas to the people who did. And that's part of the community just as much, even if it's, shall we say, intangible. So that's the critical thing, to regard oneself as part of the team rather than to believe that one can do something on one's own.
Yeah. And surely if you don't do something that wins the Nobel Prize, at least that eliminates that option for someone who might have tried to do the same thing, and therefore they have a higher chance of winning something by not
Well,
doing that.
I wish it did. A huge, grotesque problem with the way that science is done these days is that when you do an experiment and it doesn't give an eye-catching result, it's difficult to get the word out. You can talk about it on stage at a meeting or whatever, but it's difficult to publish in the top journals, which are the ones that you need to publish in order to further your career. And indeed, it worse than that. If people think you did an experiment and it didn't give a good result, they'll think, well, you shouldn't have done the experiment and you don't have good judgment about what experiments to do. Therefore, we might not give you any new money to do your next experiment. So the publicizing and publication of negative results is enormously inadequate right now. And people have, of course, known this since forever, and they've tried various ways to fix it, and it's all been completely unsuccessful. It's a huge problem.
Surely that can slow progress as well.
It enormously slows progress, no question. And the only way to fix it, really, is to change the entire culture of science. For a very long time, at least a century, there's been a particular mechanism for allocating money to do science from the public purse, and indeed from the major mainstream foundations, that's called peer review, which means that basically a bunch of experts in the same field or in closely related fields will adjudicate as between a whole bunch of different applications for money, which means you have to persuade people in advance that the experiment that you want to do is promising, which is completely backwards. It's 180 degrees antithetical to the way that science should be done. The way science should be done is you should be in a minority of one as often as possible, right? You want to have new ideas that are perhaps counterintuitive to your colleagues and bloody try them. And it's extremely hard to do that. Basically, the main way that experiments like that get done is by somebody applying for some harmless, fashionable experiment and getting the money and then spending it differently, which is...
Yeah. So it should be a process of elimination which precedes innovation.
Well, really, people should get the money for research on the basis of track record, not on the basis of grant application.
And if you could make one breakthrough or be known for one thing personally, what would it be?
Oh, I don't give a damn about being known. I have quite enough adulation as it is. But, of course, the main thing I want to do is kickstart a proper COVID-scale war on aging. I want to make enough of a breakthrough. I want somebody to make enough of a breakthrough to get the world to really believe that aging is malleable and amenable to medical control.
And would like half the population have to drop dead suddenly because of an age-related thing for it to really kickstart like it happened with COVID?
That's a very important question, a very big question. At the moment, my efforts to make aging the new COVID, as I like to say, revolve mostly around making progress in the lab. And that may seem weird because the public don't care about mice, so why would that matter? Answer is because it does matter to the subject matter experts. And those of us in the field of the biology of aging who do a lot of podcasts and stuff like that, there's not very many of us. If you actually count the number of people who, in my field, who do general audience stuff more than once a month, it's only a dozen. It's ridiculously few. And if those people start demanding a COVID scale war on aging, then it's a bit of a different matter. And they would do so as a result of dramatic progress in the laboratory. How would it work from there? The public don't care about scientists either. The missing link, the bridge between the subject matter experts and the public, is influencers. So we already have the rather fortunate fact that the world's top influencers are already really interested in this, and they don't mind saying so. No, I've been on Joe Rogan twice. David's been on Rogan a few times, various other people. And it's not just Rogan, Oprah Winfrey, Lex Friedman, Mr. Beast, they've all done this kind of thing. So they are primed. They are ready to come out and demand a war on aging just when they are, if you like, given permission to do so by a sufficiently dramatic change in what the experts are saying. And that will be enough. I have no idea why it is the case that when Oprah Winfrey says on TV, buy this book, millions of people immediately go out and do so as if they were in a trance. But the fact is, it's an empirical fact that happens. And as I say, it's not just Oprah anymore.
Yeah. So it's basically once that major breakthrough happens, then the influencers will be able to leverage that and hopefully create widespread change.
I believe so.
Hopefully. Fingers crossed. Aubrey de Grey, ladies and gentlemen. Aubrey, really appreciate your time and love the work you're doing. What are you currently working on at the moment?
Well, it's a combination experiment. Or actually, to be more precise, I'm working on raising the money to do the combination experiment.
Yeah. And where can people go if they want to find your work?
They can go to our website, LEV Foundation, levfoundation.org. And yeah, it's all there. And there's, of course, a nice friendly donate button, but there's also lots of information about what experiments we've done, what experiments we want to do.
Brilliant. And I'll leave a link to those in the show notes below for you.
Very good. Thank you so much. And thank you for having me on the show.
No worries. Thank you very much. Got to the end of this video, then you're literally in the top 1% of minds on the planet. You're curious, you love podcasts, and you love this show, but you also probably want to start your own show as well. And this is the exact same position I was in about a year or two ago, where I consumed so many podcasts and loved every second of it. But in the back of my mind, there was always that thought, I want to start my own show. But the problem was, all these podcasters that I listened to didn't have a step-by-step blueprint that would help me avoid the mistakes that they've made and create my own pro show like the ones that I listened to from them in a fast amount of time. Luckily for you, I've solved this problem for you. I've created my step-by-step pro remote podcast blueprint for the kind of person who wants to start a podcast from scratch, but has no idea of what equipment to use, how to find guests, how to actually record it, even on their laptop if they live in the middle of nowhere and don't have a studio, which, let's be real, most of you probably don't have and you don't actually need, and want to grow their show fast, generate viral social media clips, and actually turn podcasting into not just a dream, but a genuine career that they can make money from. If you're interested in this, it is literally a video course that goes through every single step and process that will get you from no idea of how to start a show, no idea how podcasting works, to a pro remote podcaster who has the potential to generate viral social media clips and get their dream guests on their show in a matter of weeks. And as well as the video course, you'll also be able to join live weekly calls with me, where I'll go through your show and give you personalized feedback of how to improve to get you results much faster. You'll also get access to the AI email templates, the AI research templates, the title and thumbnail templates I use to get super high personality guests, super high performing guests, and at a really good conversion rate. A lot of the emails I send do end up getting yeses for people coming onto the show, as well as generate super engaging thumbnails and titles, and also generate viral social media clips. For example, one of my social media clips got 1 million plus views on Instagram and TikTok of the same clip. So this is proof that it works. And if you want to get all of this and genuinely become a pro podcaster super fast, even from your bedroom, then this is for you. And alongside my templates, you'll also get an ebook, which goes into even more detail about not just my show and how to create your own pro show, but also other successful shows and the tactics that they do to blow up on social media and generate a loyal audience that they can actually teach, but also make a career from as well. So if you're interested, then it's the first link in the description. You won't regret it. I know you've been dreaming of creating a podcast your entire life, or for at least a year, 6 months. And this is the best opportunity you're going to get. And I don't know any other pro podcaster that I listen to, that I love, that has a step-by-step blueprint of the exact things they do to grow and continue to succeed at their show. So this is the once in a lifetime opportunity for you right now. It might have changed since if you're watching this a few months later, but right now you can get the founders pre-sale price. And basically, once 25 members join the community, the price will double. And also, if you don't feel satisfied with with the course and with the community, and you have followed all the steps, taken all the notes, taken all the action, and if you don't feel like you're at least 5 times more confident at podcasting and don't have a remote pro show all set up and ready to get your dream guests on to your show and create a super awesome podcast, then I'll give you your money back, no questions asked. So if you're interested, first link in the description. Your future self will thank you. I'll hopefully see you there. Goodbye.